Okay, so we're going to have our topic 5 about data description. Okay, we are having 3 subtopics, which is the first subtopic, representation of data. So the learning outcome in the first subtopic that you're going to have is identify discrete and continuous data, find frequency distribution, relative frequency, draw histogram. We have a tree graph, histogram, frequency polygon, and cumulative frequency curve. I think the new graph that you are having for this syllabus for this year will be cumulative frequency curve to illustrate data and construct stem plot to represent data. Okay, so some introduction, which is you can read by your own here. Statistics is what? Statistics is a group of methods used to collect, organize, presenting, and analyzing data. What you already did actually during your lab session, after your lab session, right, to represent your data, represent your experiments, and so on. Statistics has a wide range of uses in the field of science, business, industry, economy, medical, education, and so on. Okay, so example, in the field of science, statistical techniques are used to analyze data that is created from an experiment, which is in manufacturing, in business, in education, in health, as we have every day the data that's showing about the COVID-19, right? Data is a collection of observation, measurement of or information obtained from study that is carried out. Okay, there is 2 types of data. Qualitative. Qualitative is what? As an example, the calories, grade, and type of transportation, which is it is a qualitative. Or maybe your name. Okay. Let's say you are given a form. Okay, borang, you are given a form. You need to write your name, your date of birth. Okay, so that's a qualitative data. Quantitative data we can obtain from quantitative information. As an example, your temperature, your time, length, mass. Okay, more to quantity, which is you can count on it. And data is obtained from quantitative information can be divided into discrete or continuous. Discrete, we can count the data. As an example, the number of cars, the number of children, which is we can count 1, 2, 3. Continuous data is what which is we need to measure, and which is we have a few methods on how can we measure the for the continuous data. As an example, our length, our weight. Okay, maybe one of your friends is 59 kilo and you are 50.5 kilo, something like that. And then which is money rainfall. Okay, you can see it from here. Okay, or maybe your height. Okay. Population and sample. What is population? It's a set of units or elements, which is either people, objects, or events, which is that the researchers or the person are interested in studying. As an example, all registered voters in Sarawak, okay, or maybe all employees in Maybank. So dalam Malaysia ada banyak Maybank kan, so all the employees in Maybank and all the proton card owners, all the new cancer patients. Okay, a sample. What is sample? Sample is randomly selected from the population. Okay, contoh tadi population, all employees in Maybank. But for sample, maybe a researcher just want to study the salaries of employees in the banking system. So in Malaysia, so randomly select 1800 employees from the bank. Okay, so dia cuba pilih a random from a random population. Okay, randomly selected from the population. Okay, to represent the population. As an example, maybe you are having contoh SPM's candidate in Malaysia. Okay, for this year, for 2020, for the last year, 2020, right? So how many of them? Okay, so maybe 100 people, okay, in Malaysia will be going through SPM. Okay, so but we have we cannot have all the students 100,000, no. So we are just going to choose randomly. Maybe we are going to pick one school from from Pahang, one school from Kelantan, and so on to represent our population. This is just some example, okay? So I hope you're clear the difference between population and a sample. Okay, so let's proceed. Raw data. Raw data is what we are going to represent raw data as ungroup or group data. But first of all, we are going to have our ungroup data. Ungroup data ni kalau data kita tak banyak, kita boleh kira lagi dengan jari and so on. Okay, as an example, only 20 families. Okay, so you can see from here the sample or the data that we're having only 20. So number of male children is 0. The number of families only 2, and the number of male children is 1. The families that we're having is 5, and so on. So you can see from here. I think that you already learned that we're having mode, median, and mean. So mode ni yang paling tinggi. So you can see from here the frequency, the mode is 7. So the number of yes, the frequency is 7. So the number of male children in the families is 2 lah. Okay, the frequency is 7 families that we're having there. So median, which is we'll be having n plus 1 over with 2. So in this case, we'll be having 20, right? So 20 plus 1, 21 over with 2. So we'll be having 11. Something there. Okay, 10.5 actually, 10.5. And so we are going to find which one is 10.5. And the mean here, mean, which is we'll be going to have sum all observations divided by the total number of observations. So we're going to have this one. And the range, we will be having highest observation minus lowest of observation, and quantiles. Quantiles, we have quartiles there, which is we're going to have quantities which divide sets into the number of equal parts. Okay, so let's proceed. Quartiles, we will be having Q1, Q2, Q3. Q1 will be having 1 over 4 from our n, and which is 3 over 4 from our n is our Q3. Okay, so we will have example 5.1 here. Find the lower quartiles and upper quartiles of the data below. Okay, to find the lower and upper quartiles, you need to arrange the data sequentially. So you can see it from here, 14, 15, 18, 20 until 59, the highest one. So we are going to count. If we try to look at the data, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 data. So we are going to have just try to have 1 over 4 out of 11 and 3 over 4 out of 11. What will be you get? So 1 over 4 out of 11 is something 2.75, approximately 3, and here 8.5, you'll be having approximately 9. So you can see it from here, the which is the first quartile will be having 18, which is 1, 2, 3 just now, which is count, and the third quartile just now we just count, calculate approximately 9. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. The ninth data is 45. So the third quartile is here. So having the same thing for question B, you need to arrange it properly first, from the lowest to the highest data. So you can see from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here we are having 10. The median or the median is our second quartile actually. Okay, we'll be having here between of 22 and 23, and the first and the third quartile is 19 and 31. Okay, so let's proceed the deciles and percentiles. Okay, so if you try to look at here, I'm just going to proceed. The D3 is equal to P30 actually, so D9 is P90. So percentile is more to the 100%. Deciles is out of 10. So you can see from here, if you try to have number line, so the P will be having percentiles P10, P20, P30, P40, P50, 60, 70, 90, and which is this is the largest value. So P10 is equal to D1, P20 is equal to D2, and between of P20 and P30 and D2, D2 is our Q1. P50 is D5 is our Q2. Between of which is 3 over 4, so above 3 out of 4 here we'll be having P70, P80, C7, D8 in between of it. So in our third quartile there. So then we are going to proceed. Percentiles and distance of ungrouped data, we are having the formula, which is first step you need to find the value of R. R is nk over with 100. So then the next one, if R is an integer, so you'll be using this formula, pk is equal to 1 over 2 xr plus 1. But if R is not integer, so we'll be having pk is equal to xi plus 1. Okay, we are going to see it from the example letter. So interquartile is what? Q3 minus Q1. So after you've got the third quartile, you are going to minus with the first quartile. So you will be having our interquartile range here. Okay, so the interquartile is 1 over 2, half of the interquartile, and percentile range will be P90 minus P10. So example 5.2 is still ungrouped data. Okay, the times taken should be put in mind. They differ in 20% computers. Okay, this is a minute. Which is we are having 20, the n is 20, so we need to find the P30 and the 7. So in the first place, you need to arrange the data sequentially, okay, in ascending order, 10, 11, 12, 14, 15, 15, 16, 17, and so on here until the highest is 36. And we know that the n is 20, the k is 30 because we are going to find P30, right? So it is 30. Hence, we're going to use the formula nk over 100. 20 times 30 over 100 is 6. So R is an integer. So we'll be using the second formula, which is that you have this now, which is this one. In step 2a here. So you'll be having that one since the R is integer. So then the next one will be having 1 over 2 x6 plus x7. So count, we'll be having 6. 1, 2, 3, 4, 5, 6. The 6x6 is equal to 15. The x7 is equal to 16. So 15 plus 16 divided by 2 will be 15.5 here. So that's our P30. And D7 is equal to P70. Still having the same formula, P70 here. And k over with 100, which means 20 times 70 over with 100 is 14. So we are going to have our R is in integer, so we are going to count which one is x14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, which is 29 plus 29 divided by 2, we will be having 29. So I hope you're clear about this part. And then example 5.3 is still ungrouped, but it is they already put it into the table. So find the median, lower quartile, upper quartile, and interquartile range. So we're gonna have this one. The n is 45, so you can count, you can calculate all everything here. We'll be having 45. Actually, it is a cumulative frequency. It already cumulated. Number of families is 4, 7, 12, 10, 7, 5, right? But you just need to have 4 here, and 4 plus 7. 4 plus 7 is 11, and 11 here plus 12 is 23. 23 plus 10 is 33. 33 plus 7 is 40. 40 plus 1 is 5. So this is cumulative frequency. Okay, why we're going to have cumulative frequency? Because we are going to have it in this way, which is Q2. Since we want a median, right? Q2 is the 32 value, which is 45 divided by 33, right? So Q2 is 2 here, which is okay. So let's see how can we calculate the median. Okay, the median is 1 over 2. We know 1 over 2 out of 45 is 22.5, right? So 22.5. If you try to look at the cumulative frequency, 22.5 is somewhere over here actually. So that's why the Q2 is 2. So I hope you're clear about this part. And then we are going to find our the lower and upper quartile, Q1 and Q2. So Q1, we know that we will be having 1 over 4 out of 45 is equal to 11.25, and Q3 is 3 over 4 out of 45. It will be equal to something like 33.75. So you can see over here, which is for the Q1. Q1 is 11.5 is located between 1 and 2. That's why we'll be having Q1 is 1 plus 2 divided by 2 is equal to 1.5. Which is this one. I hope you're clear about this part. Okay. And then Q3. Okay, Q3 here we just need to have some correction. Q3, if you try to look at here, we are having 33.75 just now, right? Because 3 over 4 out of 45 is 33.75. 33.75 is located between of 3 and 4, so we'll be having 3 plus 4 over with